In this video, we're going to look at polynomial functions and their graphs. Let's look at the definition. A polynomial function of degree n is a function of the form p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus all the way down, skipping is however many terms you need to, all the way down to the last two, a sub 1 x plus a sub 0, where n is a non-negative integer and a sub n does not equal 0. The numbers a sub 0, a sub 1, all the way up to a sub n are called the coefficients of the polynomial. So here are the coefficients of the polynomial. The number a sub 0 is the constant coefficient or constant term. The leading term of a polynomial, a sub n x to the n, is the term with the highest degree. The coefficient of the leading term a sub n is called the leading coefficient. So it's only the number in front of the term and it's not the entire term. Let's look at an example to show how this actually works now that we have all this vocabulary. Suppose p of x is equal to 6x to the 5th minus 3x to the 3rd plus 5x minus 1. What is the degree? The degree is 5 because the highest degree exponent is 5. What's the leading term? Well, similarly, the leading term is the term that has the highest exponent on it. So that term is 6x to the 5th. Remember, terms are found between plus or minus signs. What is the leading coefficient? Well, the coefficients are numbers, so the only thing we can take from the leading term is the 6, because the 6 is a number, not a letter. And lastly, what is the constant term? The constant term is the term that doesn't have a letter attached to it, so that is negative 1. Let's graph some different examples and determine which ones are polynomials. The graphs of polynomials are smooth and continuous without any breaks, holes, cusps, or corners. An example of a break or hole would be something where your polynomial may be moving along, but then all of a sudden there's either a gap or there's a change in height, and then it continues on. A hole would be an open space on your curve where there is no value. This is not a polynomial. We'll say it's not a continuous polynomial. An example of a cusp or corner would be something like this. Maybe you have a curve coming up, and then maybe you have another function curving up. Maybe it's a piece of a parabola, let's say. These do not look like nice shapes. This would be a corner. And if it comes up steeply, almost to a vertical line, and then it falls back down again and decreases, that's called a cusp. So these are all things that a continuous polynomial is not. Again, not a continuous polynomial. So it's quite easy to draw a continuous polynomial. It's just something that smoothly passes a vertical line test. And there's, infinite numbers of those types of polynomials. Think of it as, can I actually walk on this if this was a hill and I was looking at elevation? Might be a little steep, but yes, there's no holes where you're going to fall through into a ravine. There's no cusps where you're going to impale yourself. And there are no corners where you might, fall back down the hill. So this is an example of a continuous polynomial.